Hello Gators, this is lesson 1-1, day 2. Let's continue with our defined terms here. And one of our defined terms is that we can label this figure as an angle. And that's the description. And the angle has different parts. This is called the vertex. And it is the point at which the two rays meet. And then one side of the angle is called a side, and the other one is called a side, and these sides are rays. So how do we write it in the sentence? Well, we write the angle symbol, angle, and you can label it with the vertex, angle Q. You could also label it with a number inside, and so that number inside says look over here at angle 2. The other way to label it is with 3 letters, making sure that the middle letter is the vertex, and it doesn't matter if you do it in reverse, but make sure the vertex is in the middle. So these are the 4 ways to label an angle. All right, I'd like you to stop the screencast and see if you can answer questions on vocabulary for an angle. Here are the answers. Let's take a look at the protractor postulate. The protractor postulate is like the ruler postulate for segments, but this is for angles. And what it says that every time we have an angle, the rays really can line up with numbers. And there are 2, like not number lines, but these the protractor designations. There's an upper one and there's a lower one. You make a choice on which one you're going to be using. Let's take a look at this situation. We're going to be reading the upper protractor measurements, not the lower one. So if we read the upper ones, this is 47, it's assigned to 47, and this is assigned to 105. Now angle BEC is a set of points. But if I want to know how wide the angle is opening, I'm looking for its measure, very similar to line segments when we were looking at distances. Now to figure out the measure of angle BEC, we're trying to figure out the number of degrees it opens. And what you're going to do is very similar to what we did with distance. You're going to take the 2 number designations, 105, and subtract the other number designation. And then you're going to get 58 degrees. Most students don't want to count the number of degrees all the way to EC like we did with the number line. They just want to take the 2 numbers, subtract them, and ensure you take the absolute value. All right, I'd like you to stop the screencast and see what you can do about finding these on your own. Here are the answers. Notice that on A, I used the lower number line. That's where I got these numbers, 180 and 65. And I used the upper number line because we had already designated EB as 47, so I decided to use the one that we had already had. Let's take a look at the angle addition postulate, very similar to the segment addition postulate. The little angle plus the little angle is equal to the big angle as long as the 2 angles share a common ray. Look here, this ray, they have to share it. They have to be next door neighbors, adjacent to each other. All right, so if I wanted to figure out the measure of angle ADC, that's the big angle, I would take the little angle, which is ADB, and add it to the other little angle since they're sharing the same side. And so I would be doing 21 plus 63, and the answer would be 84 degrees. So little plus little is equal to big. Let's take a look at this problem. Notice again, they're sharing a side. Notice that angle ABC, that's this whole big angle right here, is 94 degrees. So I know little plus little is equal to big. So 3x plus 15 plus x plus 7 is equal to the big angle on 94. That's 4x is equal to 22, plus 22. equals 94. So 4x would be equal to 72, and therefore x would be 1, and then 32, that would be 8. Now it's asking us to find CBD. CBD. So the measure of angle CBD is equal to x plus 7, which means 18 plus 7, which is going to be 25 degrees. Okay, I'd like you to stop the screencast and see if you can do the second problem. And here is the answer. Let's take a look at congruent segments and congruent angles. Congruent segments are segments that have the same length, and what we do is we designate it with a tick mark. We say this length and this length are going to be the same. If I were to take this figure and move it and put it on top of this one, there would be a perfect match. This is the symbol we use. A segment, a set of points, is congruent to another set of points. We can use two tick marks so that we know that these go together and we know these go together. The same number of tick marks shows congruent segments. Angles, we use tick marks that are curved. So these two angles have the same measure, number of degrees. If I were to take this angle and move it over here, there would be a perfect match. They would overlap each other perfectly. We use the set of points is congruent to this other set of points. Notice I'm not using the M at all. And two tick marks. If there's more than one figure and you want to show which ones go together, you look for the same number of marks. Let's take a look at this problem. I notice that I have two marks here, which means these both are going to be 32. And I am told that x, w, z, that's this whole angle right here, is 127 degrees. So I have I have three little angles that add up to this big angle. I do know that this little angle is 32. I don't know how big this angle is. And I do know this one is 32 because it's had the same tick mark. And I know that the big angle is 127. So the measure of angle YWV is equal to 64, plus 64. Equals 127, and the measure of angle YWV will be equal to 63. So that's how many degrees? 63 degrees has to be here in order for all three of those to add up to 127. Let's take a look at this problem. We're being asked to find HF. HF has two pieces, a 2 tick mark and a 1 tick mark. I see another 2 tick mark is over here and it says an 11, so I know this has to be 11. So this will be 11, and GF is a 1 tick mark, and 1 tick mark is way up here, and that's designated as 8. So knowing that those tick marks mean the same, then this will be 19. So distance HF is equal to 19. So this length is 8, so this whole length will be equal to 19. Let's take a look at, in a context of a little bit more algebra here, I'd like you to try to do this problem on your own. Stop the screencast and see what you can do. Okay, so hopefully you try this and we can see that NOQ, that's this big angle right here, is 114. So we have three angles that have to add up to each other, and then that will be equal to 3 angles, and that will be equal to 114. And we can see NOP is 2x plus 2, and then these two are going to both be the same. And then the rest of the algebra looks like this. And then your answer is going to be 15.25. Let's take a look at the next vocabulary word called angle bisector. And bisector means to cut in half into 2 equal measures. So this angle bisector makes this angle and this angle congruent. They're both the same. And here's the symbol that these two angles both are going to be congruent. Let's take a look at this. LN bisects JLM, and it bisects it over here. So we want to find all of these angles. We know that JLM is 26 degrees. And since this is an angle bisector, I know this angle and this angle are the same. So this one will have to be 26 degrees as well. And little plus little equals big, and so that big will be 52 degrees. Stop the screencast and see if you can do the next problem. And here are the answers. Notice that I gave you the big angle, 150, so you had to find the two little angles. Let's take a look at what we've been doing using distance and using angles. And let's talk about some vocabulary used in Algebra 1. Reflexive means something is equal to itself. Symmetric means that something is equal to something else, then they're equal in reverse. And transitive means if two things are equal to the same thing, if they're equal to the same thing, then these two things must be equal to each other. And that's a transitive. All this you learned in Algebra 1, and in geometry we have the same idea but with congruence. Something is congruent to itself, segments are congruent to itself, angles are congruent to themselves. Two angles that are congruent in reverse, and two angles that are congruent to the same angle must be congruent to each other. All right, I'd like you to name the property that illustrates each statement. Stop the screencast, see what you can do. Here are the answers. So these are congruent in reverse, so we say symmetric property of congruence because that's the symbol being used. This one is a reflexive property, but not a congruence of equality. The next one is transitive property of congruence because they're congruent to the same angle.